Hello, everyone. My name is Amit Patwardhan. I am currently a PhD candidate. I'm supposed to defend my work on 21st of November this year, so almost at the end of it. So I'm presenting on behalf of my professor today. He would have presented, but has another meeting to be. Okay. So, intelligent asset management, did he give me the wrong slide set? No, he did not. We will be talking about data. Let's see how we go about it. So, Ramin, he is basically from the division of operation and maintenance, which I also belong to at LTU. He has about 20 years of experience in industry, in computer science background and computer-related industries. He is currently a professor for about 10-15 years now. He has had industrial experience. He has started his own companies at times. And he has his projects listed in top 100 in EVA as well. So has a pretty good background in how computing comes into and how industry comes into and where the academia lies in all of this story. So asset management, let's start thinking about what do we mean by asset management and how do we think about it. So what is asset if we begin with? We basically say something that can create value or somebody believes that it will create some value in the future. So that is what asset is. And then we say, in order to realize value from the assets, we need to do balancing of costs, risks, opportunities, and what kind of performance do we get out of it. So we need to look into the asset is there, but what will create value out of that asset? And when we look at, okay, in order to make that happen, what kind of issues do we need to look at? When we look at from an industry point of view, it is not just about, okay, this is an asset and we can just go about it. There are a lot of other things that make sense than when it comes to an industry. It has to make sense business-wise, but it has to make sense to the government. Are you allowed to do what you plan to do? What kind of methodologies, what kind of technologies, what kind of tools are available? Will they be available in 5 years, 10 years, 20 years down the line? How do we switch? So they have to plan about all of these things before they can jump into and start optimizing things. When we think about assets, what is an asset? Malbanan is an asset. If LKB loses 1 day worth of transport, they lose a huge amount of Swedish crowns. Or a cruise ship, that's an asset. Yes, that is how we think. But then technology changes. So where are we today now? So we say, okay, some evolution has happened. And what evolution happened is we went from steam to cloud. So steam did power the first industrial revolution. We got a lot of work done through that. But today, we don't see any more of that. Today, we see everything somewhere else in the cloud. And that is what is empowering us. The idea of utilizing digitalization or digitization as the first step, you convert your analog data to digital data. Then you do digitalization. How does that zeros and ones start making sense? And then you go to eventually making money out of it, digital transformation. So there are 3 stages of how digitization ends at digital transformation. And then we talk about, can we go and take care of industry with this? And how do we bring in human-centric, sustainable, and resilience in all of these stories? How does all of this connect together for us? What is going to happen? What will happen? If we think about what should I do today, it is better to think about what will happen in 10 years and then do something today. And for that, if we look at what kind of technology trends are being forecasted, we can see there are a bunch of things that will happen. There will be improvement in computing. There will be different kind of architectures. Possibly, we might end up with some better supercomputers with completely different technology, quantum. We might end up with a AGI. We may not. And we still have to program using ChatGPT. There might be something in biology, which is dependent on how computing advances today. So there will be a completely different world where we will be. Okay? If we just look at the green things in this one, we forget about everything that's written, we can see there will be cyber-physical systems, robots, automation, AI, digital. Where does all of this get centered? It gets centered on the concept of digital data. We need that. There has been a problem. The problem is industry wants results. They say, okay, we want something better to do. We want to improve our processes. How do we do that? So we say, okay, in order to get those results, you perform certain actions. Are we doing the things right? We need to measure it. But that is based on assumptions. Are we doing the right things? And eventually, it depends on which context you are working. The same industry that can do something in Sweden, they might not be able to do same thing in a different country. The governance changes. The environment laws are different. So they need to evaluate all of these feedback loops in order to be sure that they are doing the right things. So what does that mean? Where are we today from all of this? That means there has been a problem. The problem is, when we talk about one of the core industries, LKAB or Saab or one of these, when we talk about data, for example, let's say data security, they say, no, this is not what we do. We make something else. We make steel, we make iron, we make something else. Data is not done over here, not our job. And that is a problem. Why? Because if they don't understand their own data, how the hell am I going to make some sense of that data? They have to first make sense of that data, and that is where these loops become important. So they are supposed to help me with this context. Where is this data going to be used? I can make pretty graphs. Are they useful? They are possibly not. So what is an important asset over here? The most important asset certainly becomes data. If they don't understand their own asset, we cannot understand it. We cannot do anything with that. So we need to bring in these ideas that have been there in the industry, which they have used for possibly 30, 40 years already. They understand them well, but connect it to where does it go in the future. Asset was iron, it was steel, but data is also an asset. Let's understand it in a better way. Do we have more methods to understand it then? Possibly yes. How do we do that? Why do we need data? That data can be processed and we generate some information. That information generates knowledge for us. Eventually, we might gain some wisdom. We come another way. If you have wisdom, why? Because there are people in the industry who have worked on that process for 30 years. Somebody has worked with a machine for so many years. He knows, he goes and touches the machine and says, she doesn't feel well today, right? Why does he do that? He understands, okay, there is some vibration over there, which signifies there is something wrong. There is some data, but there is all these stages of processing which happen autonomically. There is something inside him, the gut feeling. We need to take that out and somehow start utilizing it. If we are not doing that, that knowledge will be gone in 10 years, irreplaceable. We cannot replace that, right? So we need to think about the life. We need to think about the entire life of the system. From its conception to its retirement, this is the entire life. How do we do that? One of the methods we are going forward with, one of the methods in which we are working with, is basically development of digital twins. Can we start developing these digital twins and basically think about the entire lifetime of an asset and then make something parallel that would mimic the lifetime of that asset digitally? Okay? Another concept, or the division that I come from, is basically called the division of operation and maintenance. There is a huge amount of mathematical theory about how maintenance works, what is reliability in the background, and so on and so forth. This is known knowledge. Is this knowledge not useful in this age today? People will tell you, reliability, okay, that is just failure and MTBF and these kinds of things. But that is about how do you perceive what kind of performance your asset is going to give. Does it imply that data is an asset now? Yes, it does. Can we bring those theories? Very much yes. So how do we think about it? Let's stick to the theory that is the old mechanical theory, but let's start thinking about data now. What is maintenance, or why do we need maintenance? So we ensure that the system delivers functions as expected and avoids unexpected consequences. Let's replace system with data. Can our data give us the function and avoid unexpected things? Have we planned for that? When the data was stored, was it planned and stored in a way so that somebody can take it and unexpected things do not happen? Has that been planned? What is maintenance? It is a combination of all technical, administration, and managerial actions. It is a combination of 3 different actions. Not only the engineer does that, even the manager does that. It has the job of the organization to say that this is our priority, maintenance is our priority. Maintenance of data is our priority. Who has to do that? The engineer who is responsible for the data, the managers who oversee generation of that data, and the organization heads who say that we want this data to do something for us. And only then maintenance of this data is possible. Otherwise, we cannot use that. Who will do the maintenance? Okay. So there are known methods. There is outsourcing, there is insourcing. Send it out, do it in-house. And then we say, okay, which is going to cost us how much? How much knowledge do we throw out when we do outsourcing? Will that knowledge be remaining after 10 years when we want to understand what our data meant? So we have to evaluate before we do that. And these are well understood theories. We have already seen these things when we talk about the manufacturing sector. We understand if you outsource everything, you cannot insource it back. It has gone knowledge. So how do you balance it out? And finally, how to do maintenance. And then we talk about theories of design out maintenance or design for maintenance. When you send a spacecraft in outer space, you have to perform it in such a way that there is no requirement of maintenance, because nobody is going to go and tighten a nut over there. If that is a requirement, you cannot work. And so you design out maintenance. The cost is astronomical, right? At the same time, if you do it design for maintenance, if you open up a car, can a certain simple person with a simple spanner do his own maintenance? Can he do that? If he can do that, yes, that is designed for maintenance. Let's replace hardware, let's bring in data. What happened with data now? Is that data in a format that it will be useful in long term? Will you be able to access that data and read from it and extract information from it? Did you design for maintenance or did you design out maintenance? It is an Excel sheet, doesn't say anything at all. This is your data, take it, do whatever. I don't understand what it is, right? Or it is, the comments are in Swedish. I don't know Swedish, what do we do, right? So when we talk about these theories, they are well established, understood, known by the industry. And it is very easy to push them so that they understand, okay, yes, this makes sense to me. Or still going further, we talk about prognostics and health management. You go to a doctor, the doctor says, okay, you have a bit of a fever. What happened? Did you eat some ice cream? Yeah, I did. Okay, so this is your condition, diagnostics. Don't eat any more ice cream, okay? Take some hot soup. This will help your health management. In the future, when the temperature is low, don't eat ice cream, prognostics. So what is your condition? Why are you here? What you should do in the future? Okay, same theory with data. Where are we now? Where is that data with us? What can we do with it? Okay, we have certain problems with that data. Why are we at that case? Why did we have those problems? How do we take it further? What do we change? Or when we take it still in deep, we have these theories which we understand of how do we analyze an asset, and let's start bringing that with the data now. Another concept, dependability. When we talk about something is dependable, we talk about, is it reliable, is it maintainable, and does it provide maintenance support? Reliability is about having a mathematical function of how well can I depend on something. Will it fail? Will it work? Will it work when it is supposed to work, for the time it is supposed to work, within the context it is supposed to work? I have certain data. Can I extract that information when I have so and so and so limitations? Can I work with that? It defines the reliability of anything. It can be reliability of data. How much maintainability is there? Will there be a bit rot? Will that data be readable after 10 years? Can I extract some information from there? We don't know. Eventually, how do we bring all of these things together? So we apply system thinking, system of systems. So our approach is, since we cannot bring in all the knowledge at a single location, or we cannot accumulate everything together, what do? Is we start creating smaller systems. But these systems, although they are independent, they are interacting with each other. And hence, we create a value. It is very easy to put the knowledge of the data with the data in a single location and make it work. But then others, as long as they can interact with this and extract information from there, this works. So continuing with dependability, what do we want? We want its availability, we want the reliability, we want to create safety for it, and we want to create security of it. So we want to do both the things. And we go on and on. We can create error tolerance. We can create survivability. There are so many theories that are available. We can just start thinking, how do we apply it to this particular asset of it? Two-headed profit of it is, one way that there are established theories which allow us to think about this particular asset. Second profit is, it is very easy to talk to the industry about it. A mechanical engineer understands reliability much well than any other concept. If you tell him, okay, data is like this, it is versatile, it has 5 V's, he tells, no, I don't know. But as soon as you talk about reliability, yes, he understands it. What do we do? So at our group, we have ended up developing something that is called as AI Factory, which is basically a cloud-based platform that allows us to develop systems pretty fast. We develop this cloud-based infrastructure, but we apply it to each and every project that we get. So there is a complete stack of things. We have data at the very bottom. Then we say, how do we get that? What kind of data it could be? It could be data from machines. It could be physics-driven information. It could be purely information-driven systems. How do we process it? And finally, then we say, can we bring in all the theories that we understand and start mixing them together to analyze it? Eventually, this takes us further, and we say, OK, we put all of this under asset management. Yes, your machine is an asset, but the data that it generates is also an asset. And the digital twin that I prepared for it is also an asset. All of this is a system. So we put all of this together, and then we work with that. Where do we work? We have been working with railways, mining, traditionally. These two are up north that has been available. We have been working with aviation for some time now, batteries, manufacturing mostly in pulp and paper. We are looking into hydropower, not hydropower. We are working with construction for some time. I will be talking about a few of these things tomorrow in my presentation. And yes, with energy as well. So thank you very much.